by performing reconnaissance through the same injection vector. What you see here is a HTML encoded query, and essentially what they're doing is using the same cast method. They're trying to get information about the role that the database server is running in as, the host name that it's on, and the type of the version of the database server that that's installed there. We see this. For this particular instance, we saw them performing reconnaissance activity not only on the database but also on the surrounding network. We've seen them running netuse commands through the SQL query and essentially trying to gain some information about the kinds of network that they're dealing with. Following their reconnaissance activity, they invariably use, or at least try to use, XP command shell, which is probably the most abused stored procedure out there. You'd be surprised to see how many companies still do not disable their extended stored procedures that are not relevant or that are not required. The problem with XP command shell, I won't harp on this. I'm sure all of you know. It allows you to run commands on the system, in the instance or in the role that the database is running as. In this particular instance, luckily, given that they had hardened the database servers, XP command shell was actually disabled. So, so given that they found XP command shell to be disabled, what could the attacker do? There's several more stored procedures that they could now use. I do have another giveaway actually. XP makecap. Does anybody know how that can be used to exfiltrate data?
Stick it on the web server.
What does the stored procedure do?
Guessing the on-flash into cabinet call?
Sorry?
The on-flash into cabinet call?
Yeah. So essentially what it does is golf ball. Yeah, I'll use it. But essentially what it does is compresses files and allows you to place the compressed file in a location of your choosing. The problem being the files you could compress may be database files. It may not always work because you probably don't have access to the location that you're going to be storing the file in. But we've seen instances where you could store it in a location that's accessible by the web application that is accessible from the internet. So as you can see, disabling XP command shell is not enough. That's not the only stored procedure that is critical and risky. What we see though is the attackers actually using ad hoc queries to try to exfiltrate data. The two queries that we have seen them use are OPENROWSET and OPENDATASET. Essentially, what they do is allow your database server to run queries against a remote data source. So it could be another SQL server. It could be any data source. It could be an Excel sheet, an Access database. What it allows you to do is run queries from the database server to a remote database server. So what we saw the attacker do, and we actually saw this in a number of cases that we've investigated, is have the database that is vulnerable connect out to a database that they control. Now what this would allow for them to do is a number of things. The first instance is stealing data. So they're going to select all of the information from their local database and copy it to the database server that they control. So in this instance, what you can see here is the UID, which is the credentials for their database server. The address has been marked out, but it's an IP address of a database that they control. And you can also specify the port that they have the database server running in. Now, typically, with proper network controls, you'd assume that egress filtering has been enabled on your firewall, and you should not be allowing access to ports that your SQL server would typically be running in. In this case, 1433. So what they do is run their database server on a different port, on a port that you'd assume your egress filtering would not prevent connections to. In this case, 443. What you could also see the attackers do is not only steal data, but insert data into the remote database that's vulnerable. Reason being, now that you have information, what you want to do is upload malicious tools and actually gain access to the network. And you can do that by inserting some malicious code into the database. And we'll see more detail on this later on. So again, the reason they'd use ad hoc queries is exfiltrating large amounts of data, uploading malware, which we'll see instances of later on, and executing a number of commands in succession. So what they do is have a database that they control that has all of these queries in a table, and then they just run the queries from that table. In this instance, luckily again for them, they had disabled ad hoc queries, so this vector did not work for the attacker. Interesting piece of information. It's this vector was actually talked about in a paper in 2002 by two people, Chris Cerudo from AppSec Inc. and Chris Hanley from NGS. And they actually published a white paper that listed how exactly to go about doing this test. And what we have seen attackers do, it may be a coincidence, but they've been following this white paper to a T. Don't know where they got their information from, but no. Now, the last resort they have is link servers, which is what our case study is about. Essentially, what link servers allow you to do is form a trusted connection between multiple database sources. So you have your reason being you want to run queries against a different data source because it hosts information that is relevant to your application. Now, what you can do is, you've hardened your database servers in your security zone that supports your web-facing applications. But we've oftentimes seen instances where this database is now linked to another database that does not have the same kinds of controls as your database server in your security zone. It's not hardened the same way. It doesn't have the same kinds of network controls that your database server in your zone has. And this is exactly the vulnerability that was exploited in this one instance. Like we saw, that disable XP command shell and ad hoc queries, and also implemented egress filtering on the zone that hosted the database servers. Unfortunately, the database was actually linked with a developer's database in the corporate network. So what we'll see is them enumerating all of the link servers and actually running XP command shell against a link server. And we'll see how they do that. So the actual layout, in fact, was the database server hosting the web server, hosting the application, linked to a developer's database. And the developer's database was in the corporate network. Did not have the same kinds of egress filtering in this zone, and did not have the same level of hardening as the main database server.
Just to comment on this slide a little bit more, if you, here particularly, you're back in your DMZ, your backend database server really should only have access to your web server, right? It should not have any internet connectivity at all. There's really no reason for it whatsoever. In this case, because it was linked through the firewall to another database server inside the internal network, which did not have the same network access controls, right? This guy, you can go back?
Oops.
Yep. This guy actually had access to the internet, right? So the attacker was able to run queries through the web server on this database server, which then redirected to this database server, which then sent information out the internet.